Nice. Nice to see everyone. I'm Leo from Alcemy, and we accelerate the decarbonization of concrete now. We've heard it many times before and seen it now in large resolution that concrete is in fact the most used building material on our planet. We're all sitting in concrete buildings and it's just huge. However, we've also heard this today. Concrete is carrying a large carbon footprint, around 8% of worldwide carbon emissions. This, of course, is a massive problem because the world's building stock is expected to double by 2060. We also heard that in the presentation before, that there's a huge urge to decarbonize concrete. Now, in contrast to my speaker before, and many people in the industry argue that cementitious materials, concrete, cannot be replaced. They can only be replaced in niche applications. But if we're talking about infrastructure, if we're talking about the developing world, and if we just look at the sheer numbers of how much cementitious materials are produced, they make up around 30 to 50% of everything we produce. This will simply not be replaceable, and mankind better hurries up finding a way to decarbonize concrete. Now, to understand how one could decarbonize concrete, let's look at how it's made and where the emissions actually come from. So it all starts from a quarry where limestone is mined. Limestone is one of the minerals the Earth's crust is made of, so it's abundantly available. Limestone is used in a cement plant and turned into cement. This cement is delivered to concrete batching units that add water, sand, and gravel to the cement to end up with ready-mixed concrete that is driven in mobile mixers to the construction site. Now, the CO2 emissions come from this particular step, the cement production. If we look closer, where the CO2 is coming from, well, we have to feed this limestone into a kiln, into a hot kiln, and there the calcium carbonate, which is the limestone, the CO2, it's a chemical reaction, is extruded from the mineral and results in cement clinker. Now this, even if I were to heat this kiln with renewables, with biomaterials, with electricity, which is, by the way, happening, these CO2 emissions cannot be avoided. They are inherent to the process of making clinker. And therefore, Bill Gates calls this the hardest to decarbonize sector of all sectors that we have. And that's why it's really mission critical to talk about this. Now, there is one pretty easy and straightforward strategy to decarbonize concrete. And to better understand this strategy, let's look at a cubic meter of concrete that consists of water, sand, aggregates, and cement, as I said before. But if we look closer to this cement, it consists of two things. It's this cement clinker that we've talked about, but it's also supplementary cementitious materials that are cheap and CO2-free waste materials or other materials from nature that we can use to substitute cement clinker. And today, the worldwide substitution rate is around 30%. So we have 70% clinker and 30% supplementary cementitious materials. Now, clinker is the material that's responsible for the CO2, but it's also the most expensive ingredient. So the holy grail of concrete batching is to reduce the amount of clinker in the mixture. And essentially, what this looks like is we're moving from here, 70-30, to something like 20-80. This is truly low carbon cement. And this strategy, all researchers in the industry agree, is able to decarbonize or to reduce the carbon footprint of concrete by 30 to 50%. Now, sounds pretty great. Where's the problem? The problem is that the concrete on the left with lots of clinker and therefore lots of CO2 is very, very robust. The concrete on the right with little clinker and little CO2 is not so robust. But what does robust actually mean? That's the key that we need to understand in this industry. And it's something many people don't know about making concrete. Concrete is not a dumb gray mass that's always the same, like we would think. concrete actually has a multitude of quality properties. When it's fresh, it needs to have the right consistency, the right rheology, even the right amount and size of air voids. When it is slowly hardening, it needs to do so in just the right speed, needs to reach the right final strength, and needs to be resistant to chemicals. So this is a multitude of properties, and these are heavily influenced by changing ingredients. They come right from nature, and changing outside conditions and weather conditions. So it's completely naive to think that once you've found a concrete recipe, you'll just keep producing it the way it is. That's wrong. Essentially, the concrete recipe constantly has to be adjusted to changing ingredients and outside conditions. And the tools to do so today are horrible. You can see it just by looking at these pictures. It's based on humans with a lot of gut feel. It's based on manual sample withdrawals, and the sampling process is very, very difficult. It either takes 28 days to wait for a result, or the tests are very, very imprecise. So there's a lot of operational overhead in ensuring consistent quality concrete. Now, for today's concrete that is very robust, as I said, we are somewhere in the bottom left corner of this chart. So we have a high carbon footprint, lots of clinker, very robust concrete that does not require high quality consistency. It's fine. This concrete can withstand a lot of things that are happening to him. But, and this is the problem, the more we move to the right, the more we reduce the clinker, the higher the required production consistency. This concrete is not robust anymore, it's sensitive. So with today's horrible tools, this means this concrete is only feasible with excessive lab stuff, excessive testing, and up to 3 times higher production costs. And this is exactly what Alcemy is working on. We believe that being able to make consistent cement and concrete at low operational overhead will become a question of survival for producers, as carbon is being taxed in the European Union and in other places in the world. And what Alcemy does is pretty simple. We ingest sensor data during production. We predict and visualize the quality outcomes to create transparency in the plant and an easy-to-use web app for people in the plant. And then we found optimal production settings and feed them automatically to plant control across cement and concrete production. This is how it looks. For example, in a cement plant, every hour we get samples from finished cement to do the predictions. In a concrete plant, we draw our data from the batching control system and from the trucks driving to the construction site. This is how our software looks in real cement and concrete plants. And this is the effect of our software. The consistency of production is improved by 30 to 50%, while the operational overhead is decreased significantly. So all in all, our technology yields transparency, automation, consistency, and a CO2 tracking end-to-end to the construction site. We are charging a recurring software as a service fee based on the savings we create. And this fee per plant is growing exponentially with increasing CO2 prices. Currently, our CO2 price in the European Union has gone from 5 to 65 euros, and it's projected to grow even more. If we look at the overall impact potential of Alcemy, the clinker substitution enabled with our technology has the potential or will save well over 1 gigaton of CO2 emissions, which is 4 times more than global aviation. And this is not only on paper, but we have shown this in the real world, because little pull from the real estate industry will accelerate clinker substitution. So we're actually working together with our customers, piloting a concrete that has 60% less CO2 emissions, have tested it in the lab, tested it on the construction site, and we're now using it in one of the largest skyscrapers in Berlin, Edge East Side Berlin, soon to be Amazon's headquarters, where we will prove with our customers that this 60% CO2 reduced concrete is feasible, and our technology significantly reduces the green premium. Join us and let's shape the decarbonized world of tomorrow together. Thanks a lot.